This is the first test of my NEA project. In this test, I'm trying to see what the program will do if the player goes to coordinates they shouldn't be able to access while playing the game. This test will cover what happens when the player goes inside of a terrain block, along with what happens when they cross each screen border in rooms where they're not supposed to be able to cross the border being tested. This version of the game is specifically made for testing it, and as a result has functions which the player wouldn't be able to use in the final product, including functions which set the player's coordinates so they're outside of the game's window past each of the 4 screen borders, and a function which will move the player inside of a terrain block. These functions will also allow the ball to return to the screen if the player can't get it back there using the game's controls. Firstly, I will be testing the bottom screen border in room 2, which has a bridge preventing the player from accessing it. As you can see, if the player somehow gets below the blocks of terrain in this room, they will fall off the screen, and will have no way to return back to it. Next, I'll be testing the right screen border in room 3, which has a wall preventing the player from accessing it. Again, if the player goes past this border, they will have no way to return back to the screen. Next, I'll be testing the top screen border in room 6, in which nothing is coded to happen when the player crosses its top border. If the player goes past this border while above the terrain surrounding the gap in the middle, they will not return to the screen. However, if they move towards the gap, they will eventually fall through it, returning to the screen in the process. To finish off testing the screen borders, I'll be testing the left screen border in room 8, which has a wall preventing the player from getting to it. Like with the right screen border, if the player crosses this border, they will not be able to return to the screen. However, unlike with the right screen border, the image of the ball will be smeared across the screen when this happens. Finally, I'll test what happens when the player gets stuck inside of a terrain block. If this happens, the player will be completely stationary until either the player moves right, which will move them to the left side of the terrain block, the player moves left, which will move them to the right side of the terrain block, or the player presses the spacebar, which will cause them to jump and fall until they collide with the terrain block which has the collision algorithm dedicated to its top side active. This may include the terrain block that the player is stuck inside. This concludes the first test. This is the second secondary test for my NEA project. In this test, I'll be investigating how the program will react if the key image is not downloaded or not stored in the same location as the program when the player opens it. When this happens, the program will crash before the title screen can load, as the image is loaded into the program's memory at the start of its execution. This concludes the second test. This is the third secondary test for my NEA project. In this test, I'll be investigating whether keys reappear in the rooms they're placed in if the player returns to the room the key was in after using it to unlock a barrier. To test this, I will pick up the key in room 5 and use it to unlock the barrier in room 9, then return to room 5 to see whether the key is still there. After the player has used a key to unlock a barrier, it will reappear at the location it was picked up from, and in addition, if the player unlocks a barrier and leaves the room it was in, the barrier will be locked again when the player re-enters the room. This concludes the third test. This is the fourth secondary test for my NEA project. In this test, I'll be testing whether the variable which stores the amount of time the player has taken to complete the game can exceed its maximum value of 5,999. In order to test this, I've edited the program so this variable is set to its maximum value as soon as the game starts. This version of the program is also coded to print the value of this variable every frame, and as you can see in the shell in the bottom left of the video, the value is not increasing at all. This concludes the fourth test. This is the fifth secondary test for my NEA project. In this test, I'll be testing what happens when the player tries to move the ball using the movement keys while it is being affected by idle acceleration. Idle acceleration is acceleration which represents the effects of gravity pulling the ball down an incline. If the player tries to move down an incline while being affected by idle acceleration, their voluntary acceleration will start at the value of their idle acceleration instead of 0. Additionally, if the player tries to move up an incline while being affected by idle acceleration, they will have to wait for their idle acceleration to gradually reduce to 0 before they can start doing so. This concludes the fifth test. This is the sixth secondary test for my NEA project. In this test, I'll be examining what happens when the player collides with the side of a ramp rather than its slope. When this happens, the player's acceleration in the direction they were moving should be reset to 0, and the player should be placed next to the side of the ramp they collided with. However, in the current version of the game, the player will actually pass straight through the side of the ramp they collided with. This concludes the 6th test. This is the 7th secondary test for my NEA project. In this test, I'll be investigating what happens when the program is run using methods other than running it through Thonny's interpreter, namely through Python itself and through the Integrated Development Environments, or IDEs, Visual Studio Code, and idle. When directly run in Python, the program will immediately crash. I believe this is because Python cannot import the Pygame library into the program's memory by itself. However, as no error message is displayed, I cannot determine why the program crashes for certain. When run in idle, the program will function identically to when it is run in Thonny. When run in Visual Studio Code, the program will not be able to open, as the IDE cannot import the Pygame library. This concludes the 7th test. This is the 8th secondary test for my NEA project. In this test, I'll be testing what happens when the player tries to move in both directions at the same time. If the player presses both the left movement key and the right movement key at once, they will move to the right. This is because the code for moving right is written above the code for moving left in the program. This concludes the 8th test. This is the 9th secondary test for my NEA project. In this test, I'll be investigating what happens when the player enters the final room of the game while accelerating. As the player loses control of the ball once they enter this room, nothing is coded to happen when they cross any of the screen borders there. The version of the game being used for this video has extra code to make testing it easier, having functions which send the player to the final room of the game at the maximum speed they can move at in the room before in both directions. As these functions have been made specifically for testing the game, they will not be implemented into the final product. When the player enters this room at this maximum speed in either direction, they will fall off the screen and will not be able to return to it nor reset the game, since inputs from the spacebar will only be registered if the ball is on the ground or the player is on the title screen. This forces the player to close the game and restart it. This concludes the 9th test.